0 to 2 pi. Now, so here, if this is 3 times pi, then that means for our theta, for theta being 0 to 2 pi, that's going to extend our solutions to 3 times that. Okay, I'm going to write it this way. So from 0 to theta to 2 pi. Now if we have 3 times pi, it's going to be 3 pi. This is going to be 3 times that, so that's going to be 0. That's going to give us to 6 pi. Okay. Okay, so that's that part. So extending it now from 0 to 6 pi. So from here, we're going to figure out what's that theta. What is the theta that will make that statement true, right? So what is this angle that when I take sine of 3 times that angle will give me root 3 by 2. Here we go. It's going to be 30, okay? So this is going to be 30. Okay. But 30 is in degrees, right? Okay, so that's going to be root 3 over 2 is going to be pi over 3. Okay. So that's pi over 3. So 3 theta would be pi over 3. Now, what is theta? Pi over 9. So if you just solve for theta, you divide by 3 on each side. It's going to be pi over 9. So that's this one here. Now what about this other one? What would this be? From here to here, the other one was 3 theta. Where's the other angle? Where's the other angle where sine of theta is root 3 over 2? Is it 2 pi over 3? Okay, if you wanted to solve for theta, what would it be? Divide by 3, it's going to be 2 pi by 2 pi by 9, not 6, yeah. 2 pi by 9. Okay. So we have pi by 9 and 2 pi by 9. Now, how many solutions can we get from 0 to 6 pi? Okay. So what we're going to do is we're going to figure out the coterminal of this up to 6 pi. So here, theta is pi over 9. Okay, so let's try this one. The coterminals of pi by 9, what do we need to do? If you do one more 2 pi, what would that be? Pi by 9, okay, plus 2 pi, what would that be? It's going to be pi by 9 plus 18 pi over 9, so that's going to give us 19 pi over 9. So The next one would be 19 pi by 9. Okay. I'm going to ask you this first. How many rotation is this? How many rounds? 3 rounds, okay. So if I put 2 pi, that's 2 pi times 1, right? That's 1 rotation after 1 full rotation. Okay. Now what about 2 rotation after that? So pi by 9 plus 2 pi times 2. You're going to rotate 2 times. So that's going to give you pi by 9 plus 4 pi. Okay.
You're dividing those, or you're cross multiplying the 3 there for the thetas?
Dividing by 3. Dividing by 3. So I'm actually going to explain it in a slightly different way. Okay, let's try a slightly different way, okay? Let's try it again. Try something different. Get rid of this. Try something different. I'm going to try something different this time. Okay, so this is my original plan. Okay, so what we're going to do is we're going to just replace 3 theta by something else. We're going to replace 3 theta by something else. So let 3 theta equals we're going to call it x. Okay. We're going to let 3 theta equals to x. Okay, so that becomes what? Sine 3 theta equals to root 3 over 2. Okay. Now because we change this into x, so sine of x equals to root 3 over 2. Now we're going to go from 0 to 2 pi. Just 0 to 2 pi for now. Where is sine of x root 3 over 2? What angles? So x are pi by 3. And what's the other one? And 2 pi by 3, right? So pi by 3s and 2 pi by 3s. Okay. Now our solution is really not x, it's theta. So what we're going to do, x is equals to pi by 3, and then x equals to 2 pi by 3. But x is, we started off with x as equal to 3 theta. So what's our theta? Theta is equals to pi by 9. Okay, pi by 9. Now over here, 3 theta is equals to pi over 3. And then how do we solve for theta? Divide by 3. So if we divide this by 3, so 2 pi over 3 divided by 3, that's the same thing as 2 pi over 3 times the reciprocal. So it's 2 pi by 9. So it's going to be 2 pi by 9. Okay.
My calculator won't do that for some reason.
Which one?
The calculation.
Can I see? Oh, okay. I think I know. Because what the calculator is reading is that this is my numerator and then this is my denominator. 3 divided by 3 is 1. So it's, if this is 1, then it's just pi. So what we're going to do is here. Pi by 3. Pi, where's your pi?
It's on the bottom.
Okay, pi by 3. I'm going to try it first. So pi divided by 3. Now divide it by 3. 1/9 of pi, which is pi by 9. Okay. Yeah, maybe just do the brackets. Is that okay? Now let's try another one, letter B. Solve the equation solve the equation 3 cos a half x minus root of 2 equals, okay, that looks complex, isn't it? Let's see if we can figure this out. Well, how do you solve something when you have x's on both sides? What do you normally do? Isolate the x. So that means bring all the x's on one side and all of the numbers on the other sides. Normally that's what we do, right? When we have this. So that's exactly what we're going to do. We're going to put the one with the x's on one side, the one with the number on the other side. So 3 times cos of 1/2 x minus root of 2 equals to 5 cos of 1/2 x. Now, can you see here, the 1/2 is actually being multiplied by x. That's what's happening in here. So we're going to bring this to the other side, and this becomes 3 cos of 1/2 x minus 5 cos of 1/2 x equals 2. I'm going to bring the negative root of 2 on the other side. It becomes a positive root of 2. Okay, so that's good. What can we do? Yeah, you can say, hey, this is 3 cos of 1/2 x and this is minus 5 cos of 1/2 x. We can combine like terms. So we can it becomes negative 2 cos 1/2 x equals to root of 2. Yes? You okay with that? Okay, we're getting closer. What are we going to do next? Divide by negative 2. Divide by negative 2. The negative 2 is cancelled. So we're left with the cos of 1/2 x equals to root of 2 over negative 2. Here's what we're going to do. We're going to let theta this time. Because if this is theta, we know that that's a special angle, right? Right? Root 2 over 2 is a special angle. So we can say let theta, for now, equal to 1/2 x. That's what we're going to do to kind of simplify things. So we can say, okay, well, if that's the case, then it's cos of theta equals to root 2 over 2. And then we'll resubstitute it later. Now, we've got to ask ourselves, where is cos theta equal to root 2 over 2?
2 and 3.
Oh, it should be negative. Yeah, negative. Thank you. Where is cos theta? What angle is the cos negative root 2 over 2? Quadrants 2 and 3. Quadrants 2 and 3. So we know it's in quadrants 2 and 3. Okay, quadrants 2 and 3. So here and there, right? Okay, well, what is theta?
45.
Yeah, the reference angle is 45, but it's in this, and here. So this is going to be 180 minus 45, 135 degrees, and then what's the other one?
225.
What's that?
220.
180 plus 45 is 225, right? 225 degrees. Okay, now, that's not what our solution is, because this is theta. What are we solving for? It's x, right? Okay, so where's x? So that means if theta is equals to 135, and we know a half x is equals to 135, so x is equals to 270. 270 degrees. Okay, because remember, we're solving for x, not theta. We're just using that to kind of simplify things. What's the other? What's going to be 225. Okay, so theta is going to be 1/2 x equals to 225. So cross multiply that. So x equals to 450. Now you look at that. I got two solutions here, but our solution is supposed to be just between 0 to 360. So this one fits in 0 to 360. This one is not, right? So therefore, the solution is x equals to 270 degrees. Because that's the one that's the only one that fits into this one. Okay. So these ones are actually just first degree equation, just to kind of look at this. So these are first degree equation because it's sine, cos, right? I get it. We're getting into second degree. What does the second degree mean? Something with a square, right? Something with a square. Now before we dive into that, I want to show you some stuff, okay? Because you're going to see something like this. Okay, so back off, figure this out. Sine squared of x. Well, what does that mean?
You have to square it.
Oh yeah, that's basic, that's identity, right? So, but if we were to write this down, it means sine of x times sine of x, right? So if this is sine of x times sine of x, I want to point this out first, because this is going to be, when we say sine squared of x, why did somebody ask, or maybe thinking about, like, why is the square here and not there? What's the difference between these two?
The function of sine of x squared is that you take sine and you square x, whereas with sine squared of x, you're taking the entire function of the sine plus the x. That's numerically attached to the
Yeah. Okay.
So it's-
Yeah. So you're talking about this one.
Yeah, so
Okay.
the sine of x times sine of x would be taking that function and taking the exact same function
And then squaring it.
and then squaring all of those points. Whereas
First
with
this one.
sine of x squared is that you take the x values of all those points, you square it,
And then you
apply
do the apply the sign. Yeah. Okay. Now, maybe, I don't know if you heard what your classmate said here. I was about to say your name a second. When we have a square, an exponent, okay, the base, this exponent applies to the one right before that, right? So when we say sine of x squared, the square applies to which one? To the x. Okay? Now if we have sine squared of x, where is the square assigned to? To the actual function. Okay? So this sine squared of x means sine of x times sine of x. When you have sine x squared, that's basically sine of x times x. You see the difference? Okay, so this is the one that we want. We want to make sure that we're understanding that, what it means. Okay, so here we go. Solve the equation for 4 sine squared of x plus 3, and then going from 0 to 2 pi. And then give the general solution. Okay, good. Here we go. What do we normally do? Okay, so we go 4 sine squared of x equals to 3, and then how do we solve for x? Divide by 4. Yes, divide by 4. Divide by 4, divide by 4, so that cancels out. So we get sine squared of x equals to 3/4. Now what do we need to do? Yeah, take the square root. Take the square root of each one. Take the square root. So sine of x is equals to, now, what was that? Root 3 over 2. Yeah, root 3 over 2. Now, when we take the square root, just like with anything, even with this number, we have to take the positive and the negative value, right? Because when we have this, sine, oh no, that's not the one. X squared is equals to 9. How did we do that? Is square root, so x equals to plus minus 3. Okay, so we have to take into account the plus and the minus. So in this case, it's going to be plus minus root 3 over 2. Okay, so we have to look at two possible things. Well, where is sine of x positive root 3 over 2? Where is sine positive root 3 over 2? Quadrant 1 and 2. Okay. Well, what is the value? What is x? We notice that this is a special angle, so that's going to be root 3 over 2. Okay, we're operating in a radian mode, so that's going to be pi by 3 and 2 pi over 3. Yes? Okay, so those two. Well, what about sine of x that's negative root 3 over 2. Where is sine negative? 3 and 4. If that's the case, what would it be? So this is going to be x is, so 1/3, 2/3, 3/3, 4/3, so it's 4 pi by 3 and 5 pi by 3. Is everybody okay? 1/3, 2/3, 3/3, 4/3, 5/3. So you got these two and these two. So these are our solutions. So the solutions are pi by 3, 2 pi by 3, 4 pi by 3, and 5 pi by 3. Now, the thing about that is these are the solutions between 0 to 2 pi. Well, what's a general solution? A general solution would be so we're going to look at the coterminals for that. Pi by 3 plus 2 pi times k. 2 pi by 3 plus 2 pi times k. 4 pi by 3 plus 2 pi times k. And then the last one would be 5 pi by 3 plus 2 pi times k, where k is an element of integer. So we got our specific solution between 0 to 2 pi, but then these are our solutions. Is that good? Let's try letter B. What do you think we should do first?
Square it.
No, this is a 2 cos squared theta minus 3 cos theta equals, okay. What would be a strategy for this? Okay. What are we going to take out? Here. Okay. What we're going to do might be factor. Right. What we can do is we can factor a common factor, right? That's what we do when we have a quadratic function. We see if we can factor it out, right? So if you have something like this, what do? You factor out the x, and that would be x minus 1, right? And then you solve for this one, what will make the 0, and then what will make the 0. We're going to do the exact same one. So, here we go. Cos squared of theta, and then the cos of theta we can factor out cos theta. Okay, so if you factor out cos theta, what's left over from this one? You get 2 cos theta minus root of 3 equals to 0. Stop right there. Does this make sense to us? Right? Cos theta times cos theta, that's going to be cos squared theta times 2. And then if we multiply this in, it's going to be negative 3 cos theta. Okay. So, we have to look at this piece. Well, what's cos theta? Where is cos theta 0? In this interval. And then look at this piece. Where is 2 cos theta minus root of 3 equals 0 within this interval? Let's start with this. Where is it 0?
No, 19 and 270.
90 and 270. Okay. Is everybody okay with that? Yeah. Because here, cos theta is 0 up here and up there. So 90 and 270 degrees. So you get 2 solutions there. Now what about this one? Well, we gotta solve it first, right? So cos theta is equals to root 3 over 2. Where is cos theta? Root 3 over 2. And you see that? So that's going to be theta at 30 degrees. And then the other one is 330 degrees. Let's take a look at the next. Oh, is everybody okay with that piece? So theta, so therefore theta r 90, 270 degrees, 30 degrees, and 330 degrees. We've got 4 solutions for that. Let's take a look at letter C. Not so bad. Okay, now this one, how do we do this piece? This side is not 0. So now we're going to do a quadratic. It's not 0 in this side, so we have to figure this out. Okay, I'll give you a quadratic and see if this is going to help us. Okay. Now you've seen that in grade 11, so how would you solve that, or how would you solve for x? Yeah, if we get the common factor from here, then this part here, this is what it would look like. Okay. Then we have to go, well, what are the numbers that will make this equal to 2? It's a little bit harder to equal to something. It's better to equal it to 0, right? Because it's a 0 product property. So this is here's a possibility. What if we bring this over there? What do we do? Factor. Okay, how would we factor this? X minus, oh, did you say plus 1? Yeah, plus 1. X minus 2. Right? Okay. Stop right there and see if that makes sense to us. This is a grade 11 topic. This is a factored form. X times x will give us x squared. X times that. And if you expand it, it's going to go back to that one. Now, what if I change it instead of x, I go cos squared of x minus cos of x minus is equals to 2. What are you going to do? Bring the 2 to the other side, right? So we can try to simplify that to cos squared of x minus cos of x minus 2 equals to 0. And then factor it out. Okay, what will give us cos squared of x? Cos of x times cos of x will give us cos squared of x. How are we going to get negative 2? Plus 1 minus 2. Okay, so it's nice to kind of connect it to what we already know. Makes sense. Oh, but it's not cos, it's sine. Okay, let's go take a look at this one. Let's do sine. Okay. So this is going to be sine squared of theta minus sine of theta equals to 2. So bring the 2 to the other side. So it's going to be sine squared of theta minus sine theta minus 2 equals to 0. So we're going to end up with a binomial times a binomial. We know that this is going to be a factorable one. Sine of x, or sine of theta. We gotta stick to what they're actually giving us. And how can we get a negative 2 at the end and a negative 1 in the middle? So that's going to be plus 1, negative 2. Okay. So, when you look at this one, we got to ask ourselves, where is sine theta plus 1 equal to 0? Then we have to go, okay, well, what's sine of theta equals to negative 1? Where is sine theta equal to negative 1?
You said to get,
yeah, okay. I'm going to pause for a second. And then I'll get to your solution.
the positive and the negative?
This too?
Yeah.
Okay, yeah. So if we go sine theta times sine theta will give us sine squared theta. And if we go sine theta times negative 2, it's negative 2 sine theta.
Oh.
So, okay, sine times sine, sine squared theta. Sine times negative 2 is going to be negative 2 sine theta. And then inside, so it's going to be plus sine theta.
Okay.
And then last is negative 2 equals to 0. Then these two can be combined. So sine squared theta minus sine theta minus 2. Yeah, okay. Yeah, so if there's something, certainly if there's some part in here that you're not quite sure of, or just make sure before we move on, ask the question. So, is everybody okay from here? So, sine of theta plus 1 is equal to 0. Then we can go sine of theta is equal to negative 1. We ask ourselves, where is sine theta negative 1? At this one here. Okay, what are we operating on? Pi's, right? So that would be 3 pi halves. So theta is equals to 3 pi halves. And that's the only one. And then we go to this side. Sine of theta equals, I'll start with this. Sine of theta minus 2 equals to 0. So sine of theta equals to 2. So where is sine of theta equal to 2? Okay. Okay, hold on for a second. Pi over 2, we're going to go here. Sine of theta equals to 2 over 1. Okay, let's see here. Sine theta equals to 2. Well, what's 2? What's 2 over 1, right? That means opposite over the hypotenuse. Is it possible to have an opposite side bigger than the hypotenuse? No. Okay. So in that case, no solution here. So if you take the sine inverse of 2, you're going to have an error somewhere in your calculator. So no solution. So what's our solution? Our only solution. Yeah, therefore, our only solution, our solution is 3 pi halves. How's that? So far so good. Last example, and wow. Solving a second degree trigonometric equation using quadratic formula. Okay, well, what's a quadratic formula again? What's our quadratic formula? X equals to negative b plus or minus root of b squared minus 4ac divided by 2a. Well, why do we use this?
It's not going to be nice.
It's not going to be nice. It's not going to be factorable, right? It's not a factorable. Like our example here, question B and question C are both factorable. So that was easy. This one, we already have an idea that it's not going to be a nice factorable number. So let's see. So solve the equation here over the domain from 0 to 2 pi. Good. So bring everything on one side of the equation. So 4 tan squared of x minus 2 tan of x minus 1 equals to 0. Okay. Now, we can try our hardest to see if this is even factorable. We won't be able to. Okay, I tried. So here's what we're gonna do. Well, okay, now over here, this is x, but over here means tan of x, right? Because this is our x, right? But it's really a tan of x. So tan of x is equals to negative b, so negative 2 plus or minus root of b squared, so negative 2 squared minus 4, a is 4, c is negative 1, divided by 2, a is 4. Are you guys okay with that piece? Yeah. So therefore tan of x is equals to 4 plus or minus root of, let's see, that's going to give you 16, 20, root of 20 over 8. Now we can do better.
Why'd you
Better
square
than-
that too? 4?
That's going to give us 4.
And the outside 4. Negative 2, negative 1 times negative 2.
Your B value.
Your first b value.
You're subtracting.
Why'd you square it? One more over. No.
This one?
Negative
Yes.
B value. It should be
Yeah, it would be 2. Yeah.
You wrote 4. Look, pull your finger down.
Oh, that's what you meant for. Okay, 2. Thank you. This one, yes. So 2 plus or minus root of 20 over 8. Okay, I think I'm getting ahead of myself. 10 of x. Now we can do better than that because I think I know what I'm thinking about when I wrote down that 4. I said that could be, 4 is a common factor. So 2 plus or minus root of 4 times root of 4, root of 4 times root of 5, that's going to be root of 20. So that's where I'm kind of thinking about. So it's 2 root of 5. See? This is what happens when you're not in a present moment. So it's going to be 2 root of 5 over 8. So tan of x, you factor out the 2, factor out 2, so it's going to be 1 plus or minus root of 5 over 8. Tan of x is equals to, cancel, 4. So it's going to be 1 plus or minus root of 5 over 4. Now, yeah, I see why that is. Now we got 2 possible things in here. How did I get 1 here? Up this one? Oh, okay. I factored out the 2. So if I go here, if you factor out 2 times 1 would be 2, and then 2 times 1 here. Yeah? Okay, good. Thank you. Thought I made another mistake. So everyone's okay with this piece, right? Okay, so now we have 2 solutions. Tan of x is equals to 1 plus root of 5 over 4. Okay, now go ahead and say, well, that's not a special angle, certainly not. So figure out the x. What is x equal to there? Now we're operating in radian mode, so I gotta make sure that I'm on radian. So you go brackets 1 plus root of 5. I gotta press the brackets here, okay? Because I want all of the numerator to be divided by 4. 1 over root of 5 divided by 4 is 0.809. I'm gonna do the tan inverse of that. So I got 0.68. I gotta ask myself, where is tan positive 0.6802? I'm gonna go up to 4 decimal places.
Yeah, that's what I get.
Okay, let's try that again. One plus root of 5 divided by 4, 0.809. Oh, okay. Yeah, so you got this one. Okay, I'm ahead of the game. So tan of x is equals to 0.809016. Yes? Yeah, that's what you got. and then I took the tan inverse. Now you do the tan inverse.
Sounds like a dance.
Did you get,
Yeah.
okay, so the 0.8, that's the tan of x. Now if you do the tan inverse, that's just the x, 0.6802. Everyone up here now? Now where is tan positive? Where's tan positive 0.8? Quadrants 1 and quadrant and 3. Okay, so that means our x value is 0.6802. That's in quadrant 1. What would be in quadrant? Quadrant 3. It would be pi plus that, right?
3.82.
Okay, so pi plus 0.6802. 3.82. And these are radians. 1/8 radians. So the 0.68 radians is in quadrant 1, and then the 3.82, that would be in quadrant 3. Now what's the other one? That's the plus. Tan of x is equals to 1 minus root of 5 over 4. So let's go figure out tan of x first, and then x. So let's go figure that out. Did you get negative 0.3090? Yeah? Okay, now find the x. So take the tan inverse of that. Now, did you get 0.2997? Negative 0.2997. Is everybody okay here? 1.25? You got 1.25? Did you still get 1.5 or 0.2999? Yeah, okay. So we gotta ask ourselves, where is tan negative? Tan is negative in quadrants 3 and quadrant 4. Okay, so this is gonna be negative 0.299.
Yeah.
Yes, it's,
Yeah.
yeah. We're good. So we got negatives, and this is negative 0.2997. Okay, so that means our reference angle is negative 0.2997. So what's our theta? Or x?
We're going that way or the other way?
Yeah, we have to go this way because the domain is from 0 to 2 pi. Not negative. So we go from 0 to 2 pi. So what would that be? It's going to be pi minus 0.2997, which is 2.84189. And then what's the other one?
5.935.
Yeah. Or 2 pi 2 pi minus that, right? 2 pi minus 0.2997 is 5.9835 radians. So we have 4 solutions. I'm going to push it down here, so therefore the solutions are x is equals to 0.6802 radians, 3.8218 radians, 2.8419 radians, and 5.9835 radians over 0 to 2 pi. Okay, in this particular domain there are only 4 solutions, but then they said state the general solution. So the general solution is R. This is going to be a good one. So 0.6802 plus 2 pi k, 3.8218 plus 2 pi k, 2.8419 plus 2 pi k, and then the last one is be 5.9835 plus 2 pi k, where k is an element of an integer. Okay. That's good.
What's, why do we have to write it in the general solution? Like, what is that for?
So later during the break, I'll type this in, and then I'll show you in a graph where that solutions are, and then we have a visual of where that lies. Okay, I'll do it for almost all of them. So do take a quick break, and then we'll go back. I'll show you the Desmos, how the solutions fit to these solutions that we have, and then we'll have a little bit of time, not quite a bit of time, but a little bit of time to work, at least get started on some of the questions that we have in our book. And also I'll give you your major hand-in assignment, and I'll talk about that, okay?